Hey class, I hope all is well at home. This lesson's about solving systems of linear equations using the substitution method. And our agenda for today is pretty much review what it means to be a solution to a linear system of equation. And then I'm just going to jump right into notes on how to use this new substitution method. Okay? And then of course there's an assignment on Google Classroom. But hopefully by the end of this video, or by the end of today, you'll be able to find a solution to the system by using this new method that I'm about to teach you. Okay? So let's just jump right in with a little review. Okay, on the last time, or what I've been trying to teach to you, is this idea of system of equations. For now, you can just think about it as two lines, or two equations, however you want. For example, in this low pixelated image that I have up here, this red line is represented by this graph, and by this equation, 2x plus 2y equals 6. And this blue line is represented, of course, by this graph and this equation, 4x minus 6y equals 12. And so what I've been asking for you to do is to find the solution to these two equations. What I mean is, on the graph them. Where do they intersect? If they intersect, and where is that location? So for example, these two lines cross at 3, 0. So when you guys are doing this assignment, you guys are graphing pretty well, so good job to you. But some of you were forgetting that what I really wanted was this point. Where is it that they intersect? Because that point is a solution. So the solution for this example is 3, 0. Okay? That's what I wanted. But don't forget this idea, because this is pretty much what we're doing. We're just trying to find, okay, we have two lines, where the hell do they cross? That's pretty much what we're doing, okay? And you can always graph and they'll always be correct, but sometimes it's not as fast, it takes a while, it's not as accurate sometimes when we have to graph or make our own graphs. So what I'm going to show you today is you can do the same problem, but now you don't need to graph it. You could just do algebra, okay? So that's what we're going to do. So the question again is, what if you do not want to graph? Well, luckily for you, there are two methods, the substitution method and the elimination method. This one is my favorite because it's the fastest. This one is okay, but sometimes this one's better than the other one. It all depends on the situation. So I'm just going to teach you both of them. That way you know how to do it. And if you hate graphing, you don't ever have to graph it. But it's good to see what it means as a graph as well, okay? So let's just start off with the substitution method. Here are the steps. I'm not going to go over them because I went over them and they're kind of confusing, so I'm just going to jump right in. But if you're the person that wants to take notes or look at the notes or the steps, here they are. But I'm going to jump right into an example, okay? So, here we go. Instructions: solve the following linear system of equations. You have an equation y equals 3x, and then 6x plus 3y equals 15. So all you're trying to do is find out, where do they cross? Or do they cross at all? We don't know, but we're going to find out. If they cross, where do they cross? But we're not going to graph them. Okay, we're going to be using the substitution method. And just don't forget, the answer is a point. Okay? So your answer is going to look something like this: x comma y, some type of numbers. Okay? So what I like to do first is just number my equations. Now I'll call that one 1, call that one 2. Okay? And the first step you want to do is look for an equation, hopefully, that has a variable isolated. Okay? A variable by itself. And luckily for us, we have one. That's equation number 1. We have y by itself. We could have x by itself, that's fine, but from this situation we have y by itself. We have y equals 3x. Okay? So what I'm going to do now is, if you notice, I have x here, y here, x here, y here. They're all pretty much the same. So what we can do is, I know y equals 3x. So I can throw this 3x this one right here, sorry, I can plug it in or substitute for this y. Because it's saying y is 3x. So therefore, this y could also be written as 3x. This is the main part right here. So when I do that, I'm going to write over here, I'm going to rewrite this equation number 2 as 6x plus, that's 3y, but now my y is going to be 3x. And that equals 15. Okay? So again, this is the most important part, so I'm going really slow. Is I noticed that equation number 1 had y by itself. Okay? That's what I want. So I threw this 3x into this y. I substituted it because it's saying y is this, so I can put this over here. Okay? And if you notice now, our new equation for number 2, there's no more y. It's just x. And that's perfect. Okay? Because now what I can do is just solve it. Solve for x now. Hopefully this part's easy for you. Multiply. I get 9x equals 15. Sounds good. Keep going. Add those two. You're going to get 15x equals 15. Divide by 15. And then you get x equals 1. So now you know that for the solution over here, x is actually 1. And if you guessed right, well, we're not done. We need to find out what the hell is y. But trust me, hopefully, that the hard part is pretty much over. Okay? To me, this is the hardest part right here, the top part. But now we know what x is, and now we can find y. You can either plug in x for here or here. It doesn't matter. I would probably do the easier one, which is this one. So what I mean by that is, since we know x is 1, I can plug in 1 for this x or the other x. But I'm going to do this one. So what I mean is y equals 3 times x or 3 times 1. And then I just get y equals, well, 3. And so my answer is x is 1, y is 3. And so that's my solution. That's where these two lines would cross. If I were to graph them, and you can check me, go ahead. That's where they would cross. Okay? So your solution, I'll write in green because green's kind of cool. Is 1, 3. Okay? And if you wanted to check your answer, just plug these points in to any equation and you'll see that they're the same. Okay? Now, that was pretty long. I do have another example, but I'm not going to put it in this video. I'm just going to have it, I'm going to do the problem for by myself and then have it up there. You're going to have these slides annotated like this, so you can just look at it. Okay? But if you have any, if you plan on doing the assignment, and if you have any questions, I'm here for you. Okay? If you want to be live, you want me to go over a problem with you live, in person, or whatever. Well, not in person, but you know what I mean. Google whatever. Then let me know. Okay? You pretty much have a free tutor right now. But if not, I hope you're all safe. Hope you're all doing okay, and I hope to hear from you soon. But have a good day.